Hello, and welcome to the No Bad Questions podcast, where I try to learn in a conversational manner by sitting down with people who have interesting careers, important lessons to tell, or inspiring stories. I hope that you learn something too. If you want to support the podcast, please follow or subscribe on your platform of choice. You can also like or comment to boost the algorithms or share out to your network to make sure it gets more views. But ultimately, and what I hope you choose to do, is listen to the very end. With that, we'll start today's podcast. Hello, everyone, and welcome to this episode of the No Bad Questions podcast. Today, I am very happy to be joined, after much work to get it booked, by Jeff Clark, PhD. He is retired from the U.S. Air Force, spent a significant amount of time during that career as an F-16 pilot, which sounds super cool, before he moved over into a more academic role. He's dual degreed as an electrical engineer. He has a specialization in artificial intelligence. After the Air Force, he went on to be a director at a very large $100+ billion company, and eventually said, hey, maybe I should do this for myself rather than somebody else, which I think is a common motivation across entrepreneurs. And he founded Redpoint-AI. They do AI as a service with a focus on defense as an industry, but they do have capabilities across industries. We've talked previously on No Bad Questions about AI. That was a bit more specific to the healthcare space. And I asked Dr. Clark to come on and educate me a little bit more broadly about the AI situation, industry, capability, whatever you want to call it, emerging in the modern world. Dr. Clark, thank you for being here with me on No Bad Questions.
Thank you for having me. My pleasure.
So the first question I had, ChatGPT leapt onto the scene a few months ago, and it has exploded awareness and concern around the rise of the AI in sort of the zeitgeist, in the mind's eye. And what I wonder on that, is this more of an awareness problem, meaning all of a sudden everybody's just more aware of how far AI has come? Or is this a situation where we're with ChatGPT and these large language models, if I'm using the right terminology, we've passed some sort of Rubicon this year?
That's a very good question. I think there's actually multiple parts to that question that I'll try to answer. To start with, ChatGPT is an amazing algorithm that's been developed out there. Part of what it can do is based on some unique capabilities that the brilliant scientists and engineers that have come up with ChatGPT have been able to do with it. But by and large, a lot of what it can do is based on its large data corpus that it's trained on. Now, this massively large data corpus that it's trained on requires a massive computational capability for it to actually be trained and then do the inferencing properly when everybody is out there, asking ChatGPT those questions. So with this large corpus that it's trained on, it comes across, and I'm not playing it down by any means, but it comes across seeming a lot more intelligent as far as the rise of AI goes than perhaps it really is, because its breadth of knowledge can span more than our minds can hold, and it can access it quicker than ours can hold, and then it can answer your questions now more accurately and more quickly with information that makes you think, wow, I can't believe I can ask it this question that's off in left field, this one over in right field, and it can come back with some intelligent answers right away. I think the majority of that, again, is just based on the large language model that it is, some of the techniques that they've developed with it, but that large data corpus that it has. And therefore, you now have this, I think, inflated sense of fear amongst people that this is the rise of AI. And I'd like to also kind of answer that, and then we'll get to the Rubicon part. In another sense, a lot of the fear and the way it's termed, I love your question because it just brings it to light. The rise of the AI makes this sound like something negative. And to be honest, for decades, we've been flooded with movies and books
Hmm.
about machines becoming intelligent, taking over, killing the human race, and there we go. That's all we ever hear. I'm trying to think. I try and rack in my brain to think, is there a movie out there where we had AI develop a machine that the singularity point happened and it made the world an amazing place, peaceful, no hunger. Everybody could do their hobbies and not worry about working. I mean, I think life was great. I don't think that movie would sell. So I don't think there is a movie like that. And so I think a lot of when we have these huge advances in AI that we're coming up with, we get this rise of the AI fear. And I don't know that it's necessarily warranted. Not saying that, we shouldn't be cautious and we shouldn't take precautions. We should. And by and large, most of us are. But, again, it's a pre-notion that we have because of what we've been inundated with movies and books.
Mm-hmm.
So, the rise of AI may not be a bad thing, to be honest with you. It could be, actually will be a very good thing because it will help us in a lot of the things we do. As far as Rubicons, with ChatGPT, I would say, we've definitely pushed some Rubicons, especially in this large language model, to be able to train on a huge data corpus and bring to bear some great capabilities in a really fast time scale. There's some definite Rubicons there. The actual Rubicons, as far as maybe some AI ML techniques possible, are there's a lot of brilliant scientists and engineers out there and in our community that are coming up with breakthroughs every day that are pushing those Rubicons and going, creating new Rubicons once we pass, some that are already out there. So, maybe we've passed Rubicon, but more than likely, it's a kind of like you were saying, an awareness or bringing it to light as to how great what we can do we're already doing. I don't know if that answered your question, but if it didn't, please ask again. I'll try better.
No, I think it really touched on all the elements of the question. And I think that your point about implied point about the negative spin on 70 years of books and TV and movies and short stories and comic books and just media is almost universally negative when it comes to the rise of AI. The most prominent perhaps is the Terminator or HAL in the Space Odyssey. One of the few positive examples I can think of, not to geek out or take us on too much of a rabbit hole here, is perhaps something like Data from Star Trek. But I don't know that that's what people think of when they think of AI or AGI. And so I wondered if you might, let's go back to some of the basics here and just, this might be remedial for someone of your background, but can you talk to the audience and educate, like, is there a difference between a meaningful difference between AI and AGI?
Yes, there is. And if you'll indulge me, and this probably
Please.
comes from days as a professor, I'd like to kind of back up a little bit more and let's talk about machine learning. So a lot of times people will equate machine learning and AI as one and the same thing. And not to keep going further back, but just to be honest, in our community, we have a lot of definitions that have multiple terms to mean the same thing, and we have multiple definitions to the same term. I used to teach my students all the time, if you're not 100% sure from the context of the discussion you're having on any of the machine learning terms, ask and be sure you're clear. It's like my father told me a long time ago. He explained what assuming does, and I'm sure you know that makes an ass out of you and me. So never assume, always ask the question, because we have a lot of terms like predictors, instance, features. Those all can mean the same thing or maybe not. It depends on that person's definition of them and what they learned. So a lot of terminology here. So machine learning and AI can sometimes be synonymous, but technically there's a difference. And the most accepted terminology here, if you think of a Venn diagram, is machine learning is all encompassing. Within that would be AI, and within AI, neural networks. That's probably one of the most accepted terminologies for machine learning and AI, but there's others. I even have my own that's slightly different than that. But just going back to the basic definition of machine learning is basically getting a machine to perform a function that it wasn't explicitly programmed to do. In other words, there's some aspect that you've coded in that it learns on its own. And we can take a quick look at this. If we want to think of a regression problem, regression is a very simplistic problem. I have input data, and what I want to do is map an equation. Let's call it a linear equation in this case, so linear regression. And I want to map a line to this data so that when I have an input that has never been seen before, I can get a result that should be within what the expectation of what I would get, right? And so to create that line, there's a lot of ways we can do that. We can use machine learning to do that. So if we think of a line, y equals mx plus b, m's a slope, b's a y-intercept, in that sense, those two parameters have to be determined based on our data. And we can use machine learning to come up with those two parameters on its own. And therefore, the machine learned what those parameters should be to best represent the data. So that's kind of a quick example of machine learning. But what it does for you is it gives you the basic understanding is machine learning is nothing more than what I told you, mapping one type of data in one data space to another data space. I got images coming in, that's my one data space, and I'm giving you labels on the outside, cats and dogs. Right. It's another data space. So I'm doing a mapping, and it's learning how to do that mapping on its own. AI takes this a step further, and this is one reason why a lot of people say AI is within machine learning, is because it can use a lot of different machine learning techniques and bring those together to represent human cognitive functions. And so AI is more specifically towards representing a human mind or human brain capability, whether it be vision, speech, decision making, to that degree, right? And there's a lot of that, is within neural networks and CNNs. That's what we do all the time. Is we take those kind of techniques and we model and mimic parts and pieces of what our brain can do. Now, general AI is a bit different. So general AI is basically the ability to create a machine that can function and think like you do. In other words, vision's a part of it, speech is a part of it, decision making is a part of it, hearing's a part of it. You have all these white and gray matter that come together simultaneously to help you reason and make proper decisions based on all these different inputs and what it's giving you. So AI is doing a lot of that help to interpret all those different senses. And AGI, or general artificial intelligence, is where you're bringing it all together, making it all mesh so that you can have a machine that can reason and make proper decisions based on all inputs, just like you do. And, a lot of times that's called the singularity point when we ever hit that point. But that's the difference between just AI and general AI. How far are we from reaching AGI, right?
Right. That was what I was going to ask next.
I knew it was coming. And then that's a good question. And it's really kind of hard to answer because like our previous discussion, we have brilliant scientists and engineers out there that are every day pushing the envelope, coming up with a great new technique, maybe passing a Rubicon, or just a great capability in the AI space, much like we saw all of a sudden with ChatGPT that causes the rise of AI fear. And that is happening today. So it's really hard to come back and say, we're 2 decades away, or we're a decade and a half away. It's really difficult. I think we are still a long ways away, but we're pushing ourselves towards it faster and faster every day.
Thank you for that rundown. I think it's important, and I really like your definition of machine learning about having a machine or a robot, a computer, do something that you didn't explicitly program it to do. I love that definition. I don't know that I've heard that before, so I think that's a good way to understand that. On the fear front, I don't think it helps. I don't think the media helps in general sometimes on highly nuanced topics. My industry, healthcare being one, AI, this sounds like being another. But within that, it doesn't help that I read articles about, I saw one recently where a recipe app with, artificial intelligence built into it was making recommendations of like bleach cocktails and things that would be deadly to humans, and then putting it out there like, you should make this. And I don't know if this is some sort of gag that somebody built it to do that, or if it somehow is coming up with these hazardous concoctions. But situations like that where the algorithm goes off the rails can't be helping this perception of the future of AI, AGI, or the singularity being negative. Can you perhaps help me understand and others understand how it could get so far off the rails? Because that's not the only article I've seen. Or would it require you to look under the hood of any given algorithm too much to really be able to weigh in on that?
Well, I'm going to weigh in anyway.
Okay.
Probably the correct answer is I need to look under the hood, but I'm just going to kind of weigh in a general sense
Mm-hmm.
from things I've seen. That is, first of all, what is it? Garbage in, garbage out, right? So how you
Mm-hmm.
train your algorithms is going to be explicitly detrimental to what kind of answers you get, right?
Mm-hmm.
So that's why having a large data corpus is really good, because what you want to do for any data set you have, let's take average size of men across the world, right?
Mm-hmm.
If I wanted an algorithm that can tell me what that average size of men across the world is, but the only sample set I take is from people in Iowa,
Mm-hmm.
I'm not going to have good results, because my
Right.
data space is huge. And I took a little area right here where I took my data and trained up my algorithm to tell me what would be the average size of men across the world. So
Right.
what you really want to have is a good data set, one where I have data across the entire data set, population data set.
Mm-hmm.
Then I can pull that in. I don't necessarily have to have every piece of data, because if I did have every piece of data and I can't build you a 100% accurate algorithm, then I'm not worth my salt. But you're going to not be able to ever get every piece of data. So you want a good sample set across your entire data population. And then you'll be able to build you an algorithm that can weigh in with very accurate results. Now, also, kind of what you're talking about too, though, I think there's multiple ways we could look at this. It kind of ties back into an AGI situation, where, and not to the full extent of AGI, where it's an all encompassing brain, but even multiple modalities of the brain coming together to be able to make a proper decision on something maybe it's not ever seen before. But if it had known that bleach was a very toxic thing to humans, then it would have never put that into the recipe as part of the equation as what to use. Um, Again, not knowing how it was trained or what it was trained
Right.
on, it's really hard to come back and say why it exactly did what it did. But it really, again, goes back to also keeping in context what you design the algorithm for and what you expect the results to be. And if you're asking it a question outside its expectations of what you expected the results, what you built it for, then don't trust the answers. And definitely don't trust the answers. Other aspects of this is a different field within AI, which is becoming very popular because of this problem. And it's called explainable AI. And that means being able to understand exactly why it made the decision it made. What were the features that were input here that weighed most heavily to give me my output, my label that I got, or my recipe that was fed to me? What did that? Why did it do that? And if it can show me this, then as the human, I can come back and go, yeah, I trust this. Or I can go, oh my gosh, that makes no sense whatsoever. I don't trust this at all. Retrain it. It needs better data. It needs to be retrained. It needs a different technique, whatever it is. But so explainable AI is something that is becoming more and more popular every day, so that it's more trust. Algorithms we develop trustworthy, other than us just going, we're really good at what we do. We've been studying this for 15 years. Trust me, it works, right? That's not going to fly for everyone, and it shouldn't. We should have confidence levels built in um, to all of our accuracy capabilities, so to help you realize how trustworthy they are. And again, I would not trust, right out of the box. Maybe not trusting it immediately unless you have all these indicators, confidence levels, explainability to it. Then yes, but if you don't, then take everything with a grain of salt. Validate, right? What is it? Trust, but validate. Validate those results yourself, and maybe after a certain amount of time, it continually giving you accurate answers, you'll build up that trust in that specific algorithm for that specific mission space that you're doing.
There's so much in what you just laid out. I want to touch on a couple things and then get into a question that comes up from this conversation that I hadn't come in with, but I definitely want to explore with you for a moment. So the first is, on the explainable AI, I've long said that that's the only way you're getting me into a self-driving car is if the decision making, like how is that car going to solve the trolley problem, right? Like I'm if I don't know that, or particularly a trolley problem iteration that includes harm to the inhabitants of the vehicle,
Right.
I know what as a human driver I'm going to do and who I'm going to prioritize. And, I need to know that. And if you want to have a brand that makes a different decision when it needs to solve that than you might, then maybe that's a brand differentiator for that car company. So that's one. Another thing that you mentioned, I think, is really important for people is if you hear some news article about how AI did some wicked thing, conversational AI decided that it was going to tell you that it hates humans, or you're going to have this recipe book, or like, unless that article is also sharing probably fairly intricate details of how that AI was programmed, you're probably going to want to grain of salt that article. And then the last thing, and this brings me to the question that I'm sitting here thinking, kind of pulling amateur psychologist. If the goal of AGI is to get a computer to be able to think like a human, and some proportion of humans are psychopathic, is it reasonable that some percentage of the time an AGI would behave in a similar way? Meaning it can be normal, reasonable most of the time, but maybe there's some day, some situation, some input that's going to take it off the rails. And I know that AGI is in the future and it's not here yet, and I'm asking you to speculate, but I mean, is that, I've never really thought about that sort of combination of variables until our conversation today. Is that something we should reasonably be thinking about and be on the lookout for if it's going to mimic humans?
So, first of all, I'll say, hopefully that won't happen. Right?
Sure.
but, but we can't just live on hope. We actually got to strive to make sure it doesn't happen.
Mm-hmm.
And in that sense, it's not the same as if I take your brain and I download it. Then there's a movie out there like that, right? Where you do with neural nets, they grab someone's memories and everything and move it over, and you create them perfectly in a machine. That's not what we're talking about with AGI. But bottom line is, it's not like we're trying to mimic your personalities to that degree, but your capabilities, your cognitive functioning capabilities is what we're trying to do. One of the things that you brought up that made me think too is, and we have a person in our company who's getting their PhD in the cognitive fields to help us keep us in alignment with when we develop AI. Not only how do we make sure that, and they understand the human factor side way better than some of us engineers. And so when we're developing it, they're closely integrated with us to help us be able to make the AI be very easily understandable to the analyst or whoever humans that are going to be using it, making it easier for them to trust and understanding, we call an alignment engineer basically for us, because keeping us in a line so that we don't go off the rails, as you might put it, and develop something that perhaps should go in the wrong direction. But more so than not, it's helping us be sure that our algorithms are understandable, usable by the humans more so than not, because a lot of us engineers, what's the saying? An extrovert engineer is someone who looks at your shoes when they're talking to you. So, our social skills aren't that great, but everybody else out there has great social skills, and they see the world differently than we do. And so it's nice to have someone help us make sure that when we develop these algorithms, that they are developed such that it's ripe and ready for them to use. It's easy to understand and it makes sense to them, and they'll trust it better. Um, and going back to I'm thinking that there's a movie, and I forgot which one it was, but it's called The Ghost in the AI, or Ghost in the System, or Ghost in the Machine. Um, to be honest, you're probably always going to have moments where your classification is not correct. Having 100% accuracy is a rare situation, and it's typically only if a certain type of data, for instance, linearly separable data set that's never, for the entire population, linearly separable. You should be able to eventually get you a good 100% accurate algorithm. But everything's usually non-linearly overlapping, and especially when we're talking AGI kind of stuff. So the fact that we'll never have 100% accuracy means that there is a possibility and a probability that occasionally we'll get a wrong classification. What does that mean? Occasionally we'll get a recipe where cyanide is in it because it made a mistake.
Right.
Now, how do we prevent that? Checks and balances, QCs, common sense. But there's a lot of different ways that we could combat that, and those are stuff like I said, explainable AI will help us fix, correct, and prevent.
Well, and that the accuracy rate is its own. Heck, you could do your own podcast, a separate podcast just on humans aren't 100% accurate.
Sure.
Now, when we're talking recipes, using that example, the odds of humans making a fatal mistake,
on purpose, right?
yeah, on purpose, low. But yeah, I think there's tons of discussion on, do we even have reasonable expectations for the accuracy rate of AI? And we could talk about that at length. Let me ask the last one. I've been thinking about in the months that we've been communicating, lining up today's conversation around AGI, and then we'll get into some more like the world today rather than looking out at the world tomorrow, which is, given that humans are so afraid of AGI because of our cultural depictions of what that would look like. If I'm an AGI and I become aware, I'm probably not going to tell you because I'm worried you're going to delete me. So by the time we realize that an AI is self-aware, is intelligent, is that likely to be much later than it actually, will we only know about the singularity in the rear view, I guess, is the way to ask it.
In my opinion, no.
Okay.
Yeah, I don't think that we'll accidentally hit the singularity point.
Okay.
And not realize it until it's too late.
Okay. All right.
Yeah.
I like nice, clean, definitive. When it comes to something like that, definitive answer is good. Let's turn our eyes more to the state of things today. All the time, here's an article on LinkedIn, here's a news story, here's whatever about a new AI startup, a new AI app, a new AI thing. And I think, for me anyway, and I try to pay attention to the AI universe. I'm no sort of expert like yourself, but at least to pay attention. Most people, I think, you can't even get their head above water in terms of keeping up with this stuff. are a lot of these startups, not asking you to throw shade on any other companies out there, but are we out ahead of our skis? Are there people just trying to live on the buzz right now, or is it really that there are that many different applications that there's a new one discovered every day, is what it seems like. Is that legit?
Um, so let me answer it this way, in the sense that we're seeing, at least I've noticed and been seeing, a lot of these startups arise because of these large language models.
Mm.
And that's because, and I kind of equate it to the .com phase, because they're taking these large language models and they're training them up for a specific purpose that, you know, a lot of people or different industry partners will have a need for, and they'll train it up for that purpose, create a software around it, and then put a business on it and sell the software. And
Mm-hmm.
good on them. I'll be honest with you. Good on them.
Mm-hmm.
There's a lot of them out there doing it. There's a lot of smart, innovative people that should be doing it. Are there a lot that are doing the same thing? Probably. Similar things, most likely. Which one, should you go with? Well, and because you made the comment of keeping your hands around all of it that's out there.
Mm-hmm.
I don't think you can,
Mm-hmm.
because to be honest with you, it's even bigger than the LLM craze that's going on, because the field itself is huge. AI/ML field is very vast. There's a lot of different fields to it, a lot of different areas, and for one person to try to keep their hands in every part of it is an impossibility. Basically, what you really want is to have a bunch of engineers and scientists that span. They have their own expertise, but you have a lot
Mm-hmm.
to span that entire breadth. Um, Now, as far as that goes, then yeah, I'm not going to throw shade, because again, these innovative people are creating products that are capable and they are meaningful and useful to some people out there and to some companies out there, and good on them.
Yeah.
I I guess maybe, is there another question as to
Uh,
why?
Well, to me, I head with that one into the idea of build versus buy, the age old software question.
Yeah.
Because if you can't keep up with all this stuff, maybe you think, well, we'll go at our own in our company. But is there a scalability problem to that? Because as you mentioned, so much of these tools need very, very large data sets, the expertise. I mean, you've got a PhD. You mentioned somebody else in your company is getting a PhD. They need, well trained and educated technical experts to build some of this. It is build versus buy. So the question is build versus buy still a thing when it comes to AI? And is that variable based on scale? Small
Mhm.
business, you're gonna have to buy. There's no way you're gonna build. Because I think, like, not to call out names, but Automation Anywhere, my experience with them, they're more of a true automation than maybe a ML, but they have some really cool tools. But I think their approach is mostly going to be to help you build, your own, versus perhaps somebody like you. And as I understand Redpoint, from what you told me coming into the call, you guys are really going to do that for people because you're going to do your AI as a service model. And I guess I'm just asking you to weigh in on this whole conundrum that businesses are probably facing, trying to keep up with the competition and with the marketplace.
Yeah, no, that's an excellent question, and I think there's three parts there. You basically said build or buy, and I think there's build, buy, or contract out.
Fair.
Um, so my advice to other business owners, or people who are looking as to, what should I do? Do I let's start with the buy. Let's say I go out, and if I can find some software out there that somebody's already developed that will fit my purpose specifically for exactly what I need, then depending on the price, that may be the way to go,
Mm-hmm.
or it may not. You may need to, and probably should, talk to, and this is where the contract part comes in, talk to a company that could build it for you and
Mm-hmm.
see what they could do, how they could do it, and then weigh the price between the two and the capabilities between the two. Now, the problem is that not all the time, and we see this a lot, companies go out and try to find that software that fits what they want. And it usually fits anywhere between 75 to 95% of what they need. And so they've either got to accept a deficiency in what they're going to get out of it, or they really need to go and either, like you said, build their own or contract out.
Mm-hmm.
Now, the difference between build your own and contract out is a huge time commitment and a cost. So to build your own, you've got first got to go out and find these expert engineers in the field that you're talking about, be able to bring them on board. And now you've got not only their wages, but you've got benefits. And what do you do with them when you're done with your project? If that's the only project you need, now you're going to let them go. That doesn't look good for you as a company. And matter of fact, a lot of smart individuals out there are figuring this out. And before they hire on you, they want to know, what's my longevity here? Do I have legs even when this project is done? So there's that part of it. And then the contract out. Shameless plug, but companies like us, Redpoint, we can be your AI lab for you. You need a certain project done. You come to us. We look at what's going on. We tell you how we could do it. We give you a cost. And if you like it, then what we do is we build it for you. When we're done, we're done. We walk away until you need us again. 6 months, a year down the road, you have another project. Okay, let us know. So it really depends. If you can find that software out there that fits you perfectly and it's cheaper than contracting it out, it's probably definitely going to be cheaper than building your own. But if it's cheaper than the other two, definitely go for it. If it's not exactly what you want, you really should be shopping around and going, okay, what will it take for me to have my own engineers? What will it take for me to get this company to come in and build this for me? And then weigh it out that way. That's in my opinion the logical thing to do. And we saw this need a long time back, and that's one of the reasons we started our companies, because there are a lot of companies that they need AI, they want AI, but they don't really want to have their own AI engineers, because what am I going to do with them when I'm done with this one project?
Right.
Maybe I'll have more, maybe I won't. Who knows? And so a company like ours can be beneficial in that sense. Um, and you made the comment, small companies probably can't afford to do anything but buy. And I'll actually disagree with you on that. It depends. Some of our clients that we've helped in the past are small companies. And some of them that we're actually going to be helping here in the future are small companies. We also have very large companies, largest telecommunications companies in the country that we work with. It just depends on their needs. And so honestly, if you want to do it right, whether you're a big company or a small company, I would go out and look at the buy space. What's out there? If it's perfect, there's really nothing to think about unless it's just super expensive. But then buy and build. Right?
Mm.
Building's pretty tough unless you've already got a team. And it's not a build. It's just you tell your team to do it anyway, or contract it out. So look at all the options. That's all there is to it. Just go out there and look at the options.
Okay. All right. Well, thank you for all the conversation today on both the current state of AI and the future, the singularity, the AGI, the rise of the AI, rise
Right.
of machines, whatever you want to call it. In the last bit of time, because I know we're coming up on time, I try to talk with guests about career path and how you got where you are and things like that. So I suppose my first question is, I mean, fighter pilot to academics and AI consultancy entrepreneurialism. Fighter pilot seems to me such a high speed profession, and I don't just, not just literally, but figuratively. You're seems like a lot of go, a lot of adrenaline, and programming and seems less, and academics seems less still. How did you make that leap? What drew you into your current trajectory?
Okay. Well, to try to keep it as short as I can within our time frame. Growing up, I always wanted to fly, but I always loved making things work. I loved
Mm.
figuring out how I can rig up a door to electronically open by pushing a button. This is way back in the day. And so I love doing that kind of stuff. So when I went to undergrad, I did double E because it excites me. And I wanted to have that background and that knowledge. And to be quite honest, and since I love flying too, I pursued that very heavily. And as you know, ended up getting a 16 slot in the Air Force. But I would be what I would consider, and what I've told people before, a closet engineer. And there's a
Mm.
reason I say that, because uh, in the pilot community, and it's a friendly rivalry, engineers don't like pilots and pilots don't like engineers, because
Mm.
pilots break what engineers have created for us, and the pilots blame the engineers. Well, the engineers come back and blame the pilots because they abused it, and that's why it broke. So, there was a friendly rivalry there between pilots and engineers. So none of my pilot buddies back when I was flying F-16s knew that I was a closet engineer. And by that, I had a Philips microcontroller programmer, an oscilloscope. I had it all hidden away in a little area, cubby hole that you couldn't have. You had to know how to wing your way around boxes to get to, and all kinds of parts. And I, in my spare time, built stuff all the time.
Mm.
I just loved programming in machine language on these EPROMs, programmed it up, made stuff with breadboards, and just had fun. But nobody knew that. Halfway through my career, I lost my medical for flying,
Mm.
and pursued the double E field. And that's how I got pulled back into double E. Always thought I wanted a master's and a PhD anyway, but so it kind of worked out that I was able to go after it. Now, the AI part of this, there was a part of me that always loved not only making things work, but being able to develop something that could think, something that was smart, something that could solve a problem for me, which was exactly what machine learning AI was. So I always wanted to get in that field, and I had the fortune to be able to actually study that as my specialty going through my PhD, and then teach it and use it and have that as my profession from there on out. So I've always loved that. And, I would say to anybody wanting to pursue an AI ML degree, there are certain universities that give just that now, an AI ML degree, but most of the times your degree is in a different field, whether it be computer science, computer engineering, electrical engineering, or even something different than those. Those are the most common ones that you specialize, take a lot of courses in AI/ML. And that's typically the way people go about becoming engineers and scientists in AI/ML, is through that kind of method and methodology. I would say, there's a lot of value to online courses. There are some online courses that are really good that gives you deep theory. A lot of what I call brick and mortar classes at universities, that's where you'll definitely get your theory. For companies like mine, because we go into specific spaces and we will take the state of the art technology, twist it up however we need to, because we understand the theory. We can change it up and make it work specifically for your mission space. We love guys with the theory. Uh, they all have their place and time. Someone who understands how to manipulate the application is great. Someone who knows the theory is also great. So, that's kind of the path I see there for being an AI/ML engineer. Just learning how to manipulate, and also then learning how to understand the theory and getting the theory background.
And then I think last question for time probably is, you're doing this essentially as a second career. It's a second phase of your career, whatever you want to call it. And there's people out there looking at, maybe what they're doing isn't great, and they've heard so much about what's going on in AI, and maybe they want to jump fields. And then obviously young folks looking to get into it for the first time. So a two-part question: what advice, or maybe the advice is the same. What advice would you have at folks looking to make a leap into your industry? And what advice would you have for young folks looking, they're entering their first career, entering your industry for the first time?
I think they'd be about the same, and that is, um, is it something you like to do? But what you need to understand is you need to like math. There's a lot of math.
Mm.
Statistics is involved in that as well. You need to be able to understand and code. So whether it's Python, MATLAB, or R, whatever it is, or multitudes of those. You need to understand how to be able to code, because you got to be able to code to do that as well. But then you've got to have what I would consider a passion. And that's a passion for making things work or fixing things or solving problems. If you have that trifecta in desire, then I would say you're probably well suited to get into the AI/ML field. Some of the questions I've had in the past that are similar to that is, is it worth getting into that field? And I'm here to tell you, as long as there are any device that can utilize a computer in any way, there is going to be some sort of machine learning or AI involved with it.
Right.
This is not a field that's going to go away until the EMP hits and takes out everything across the world. Until that happens, this is a field that's never going away. So is it a good field to get into? Most definitely. If you have that trifecta of desires and capabilities, then pursue it and enjoy it. It's a lot of fun.
Well, thank you for that advice to folks who might be listening and thinking about this as a field. Thank you for all your input today on some of the technical definitions on the future of AI. I really enjoyed it, and you've helped me think about the topic in a different way than I might have in the past. So, Jeffrey Clark, PhD, thanks for coming and joining me on No Bad Questions.
Thanks for having me. Appreciate it.